Hi, my name is Paul Abernathy, and I'm the Codes and Standards Manager here at Encore Wire. Today, from the desk of Codes and Standards, we want to talk about different types of MC cables. Now, if you're familiar with this product, you'll know that under the National Electrical Code, Article 330 is what deals with MC or metal-clad cable. And you have the different sections that have to do with the installation process and how to secure it and support it and what have you. But a lot of people don't understand that as a manufacturer of these products, we have to construct this cable in accordance with UL 1569. Now that is the standard that we use and all manufacturers use for construction of metal-clad cable. Now, this episode, we want to talk to you about some of the basics of MC cable. Now, we do know as electricians or as inspectors or as engineers that type MC cable comes in a wide variety of types. In other words, the number of conductors and their use. So for example, I can have an MC cable with multiple neutrals. I can have an MC cable with an oversized neutral. I can have multiple branch circuits within a single MC cable. And even today we have some of the MC products that allow for us to have class 2 and 3 circuits in the same cable as the power conductor circuits, as a kind of a hybrid type of product, and we'll talk about that a little more today. But then you have your traditional MC cable, which is what you see used all over the place, and we want to show the differences between the typical normal MC cable and more enhanced MC that we call SmartGround, as well as a healthcare facility SmartGround, which is essentially the same as our SmartGround, but with one little extra component. And then we'll talk about PVC jacketed MC as well as the MC PCS or the MC LED, which is that class 2 circuit conductors with the normal circuit conductors for lighting. So we'll talk about each one of those in detail. And we'll go into some details in the different standards and how they're constructed to kind of give you an overall view, maybe that 30,000 foot view of what we're dealing with between the different products. So the first one we want to look at is normal interlocked type MC cable. Now, of course, it comes in, MC cable comes in corrugated, smooth, or interlocked. Interlocked is what we produce, so we're going to talk about the interlocked, which is probably the most widely used type MC cable in the industry. All right, now, these two products here are both MC. It just so happens that one of them has a steel armor and the other one has an aluminum armor. Now, UL 1569 lets us construct it whether it has an aluminum or steel armor. But what we like to do here at Encore is we'll actually put a color coding system on it. It's called Smart Color ID. That way, at a glance, for the inspector, the engineer, or somebody that's observing the installation, can simply look at the cable as it's installed and be able to tell at a glance what we're dealing with, whether it's a steel armor, aluminum armor, which makes a big difference when you're choosing a fitting, and we want to look at it and see what size the conductors are inside of it. So that's when you got what's called a Smart Color ID. Now let's look at these products here. Now this one here, which has a gray wrapped marking on it, and again, these are every 24 inches. And this one, actually, the gray signifies that this is actually an aluminum armor, whereas the blue signifies that this is a steel armor. Now, we talked about it earlier about fittings. If I'm going to use a set screw type of fitting, I can only use that on the steel armor because it won't penetrate through the steel. In the aluminum, you can't use a set screw type of connector or fitting because it will penetrate through the aluminum and actually could damage the conductors, and it will damage the aluminum. So we can't do that. But you can use a saddleback type, or you can actually use one of these type of fittings that push straight on to the actual cable. And we'll talk about these fittings a little later. So two different products, both are a type MC. One has a steel armor, one has an aluminum armor. Now, we also give you what's called the ID system for what type of conductors are in it and what sizes they are. So that's when you see here yellow. Now, yellow signifies 12 gauge conductors. Now, let's go back a little history. Years ago, Encore Wire pioneered the colored insulation on individual circuit conductors. During that process, they also pioneered the actual coloring of non-metallic sheath cable. So, traditionally, you're going to see this white non-metallic sheath cable. The white is going to signify 14 gauge conductors, but you might see this in yellow, and that would signify 12 gauge conductors. You'll also see this available in orange. That tells you there are 10 gauge conductors inside. And of course, next size is 8 gauge, and that would be black sheathing on that. So we kind of carried that through with the MC products. So the yellow signifies that there are 12 gauge conductors in there. But another thing you get on these markings, which again you have every 24 inches, so if one comes off, no big deal. There's plenty to look at for the markings. This one says that it's a 12-3 with a ground, so you know in here it's going to be a what? It also says here a black, a white, and a red. So I know that there's a black, a white, and a red in here. That's the 12-3. And then we have a ground. This ground happens to be insulated, green. Now, UL 1569 says that that equipment grounding conductor could be bare or it can be insulated. Most manufacturers will choose to insulate their equipment grounding conductor in a traditional MC cable. Just so you know that it's possible that you could have a bare in there. Now, with that said, let's suppose I have a typical MC cable that's got an insulated equipment grounding conductor and an additional isolated ground conductor in there. Well, the first one, which is your equipment ground, could be bare or insulated, but that secondary equipment ground, which is being used for isolated ground, that has to be insulated. That's all in accordance with UL 1569 and beyond the scope of this lesson, but I just wanted you to be aware of that. All right, so essentially the two of the same products. Let's talk about the inners a little bit. So here are the inners that are inside a traditional MC product, whether it's a steel or it's an aluminum armor. This is called a polymeric wrap material. It actually wraps all the way around the conductors in a spiral fashion during the armoring process. And we put this on there, and this is in accordance with UL 1569. It's not in accordance with the National Electrical Code. It's the construction code that we have to follow, and I mean construction of the product. So, in this standard, UL 1569, it says we have to use, for MC cable, a wrap material as a binder. Now that binder could be polymeric wrap, it could be paper, it could be an extruded material like the same insulation that's on the conductors, it could be extruded over the assembly. All of that, depending on how you construct it and how you get it listed with UL, is basically what your construction. So our typical normal type MC cable is going to have a polymeric wrap that goes around all the conductors. Now these conductors are cabled, means they're twisted together. Okay, now they're twisted prior to the armoring process. So you actually twist these, then it goes through a machine that applies this armor spiral on it that interlocks the armor as it goes through the machine. Now, once that's done, you created a cable. Prior to that, just because these conductors are twisted does not make it a cable. It's in the cabling process, but it is not considered a cable until it's a completed assembly. All right? So you have this polymeric wrap, which could be paper, which could be an extruded material. That's where UL 1569 comes in. But as you're an inspector or an installer electrician, typically you're going to see the MC cable with this polymeric material around it, protecting the conductors. Interesting note that is if we happen to use a thermal setting type of conductors, that would be like an XHHW-2, then we wouldn't be required to put this binding material on there. But since we're using a thermoplastic product, that's the THHN/THWN-2 product on the conductor insulation, then you're required to have this binding material. So that's what we do here. Now this would be the same for either one of these products here. All right, so that's traditional. Now the other thing that we have to cover, is this armor considered an equipment ground? Is this armor an effective ground fault current path in accordance with the National Electrical Code? More specifically, 250.118, which gives us the definition, if you will, of what an equipment grounding conductor can be. Well, this armor cannot be because the code doesn't provide for it. That is why we have to put the equipment grounding conductor in it. Now, let's say we want to use this armor of an MC cable as an equipment ground and as an effective ground fault current path. Then what do? That's when we come out with a product like this. Now this is a type MC cable, but it's also called a SmartGround. It's a more advanced type of MC cable. Now why is it advanced? Well, as you'll see that inside of this actual cable, and in this case with the SmartGround, you see that we chose to do actual colored paper corresponding with the conductors that are inside for easy identification, and the paper is an option for a binder that we chose to use in this product and it adds a little extra protection to the conductors during the bending radius process when you're installing a Type MC cable. And this is a more enhanced product, so we want that little more reliability in it. So that's why the paper is used here. Paper is easy to rip away and tear off, not a big deal. But what makes this special is that in this product here, which we can see with the yellow label, that this is a 12 gauge product. That means the conductors are 12 gauge. And as you see here with the purple marking, that means that this is our signature for a SmartGround product. And of course, if you didn't even know that, you can see right here it says an MCSG for SmartGround. What does that mean for you in the world of using this product? Well, this is a labor savings product. Under the normal MC, you have to terminate that equipment ground at every termination. Under the SmartGround product, you don't have to do that, because you have this 10 gauge aluminum grounding / bonding conductor that once it's installed and it touches all of the convolutions in this armor, it is considered an effective ground fault current path. And where does it say that in the standard? UL 1569 tells us what size this has to be and what it's intended to do. But then all you need to do is look at the National Electrical Code. And it'll also give you guidance in that when you look at 250.118 item number 10, sub-item B. And that tells you that when you take a bonding / grounding conductor and you put it in contact with an armor, now it becomes an effective ground fault current path, or basically an equipment grounding conductor, as stated in 250.118. So that's what we're utilizing here. So this becomes an effective ground fault current path, because this aluminum conductor touches every convolution through the entire length of that cable assembly. Now, what also makes it different is the termination aspect of it. What do you do with this 10 gauge? You don't take it into the fitting, you don't take it into the box. You simply take this, you bend it back, you cut it away just on the inside so it doesn't protrude past the outer perimeter of the armor, and that's it. It's done. Now the fitting will fit over the conductors and onto the armor without this aluminum conductor getting in the way. So we don't want this to inhibit the actual connector from fitting onto the armor. And that would do so because the diameter of this armor corresponds to the allowable diameters for this connector. And if you put this 10 gauge against it or wrap it around the armor, you're changing the OD of the actual armor, and this connector will not fit properly. And it was never listed for that type of application. So this is not the same as when you're using a product like this, which just happens to be a AC cable. And you'll notice with the AC cable, it's got a little 16 gauge wire that actually can bend back and sit neatly inside of the interstices of the actual armor, which won't inhibit the connector. You can't say the same thing for an MC cable. So keep that in mind. It needs to be cut off. It's done its job. It doesn't need to do anything else. You don't need to bring it in. You don't need to terminate it. It's done. Okay? So that's that. So now you have to use a proper fitting. So that brings us to talk a little bit about the fittings. This fitting happens to be one that's made by Bridgeport, and I actually have the box for that. And this is a unique fitting, like many fittings out there. It is a multi-rated product. In other words, you'll see here that this is an AMC 50 QI, and this happens to give you the range for the cable that this will work on right here on the box. But it also says that it's been evaluated for use for 14.2 through 10.3 cables. Okay, so with the above ranges, and it'll give you the diameters, and that's of the cable that will be provided by the manufacturer. Will tell you the range of the cable, and that's how you select the fitting. You don't simply select a fitting because you say this is a 3/8 or ½ inch or whatever. It's based on a figure that we give you at the manufacturer, the diameters, the OD, and that's how you select the fitting for use. Okay, so the other unique thing about this fitting is that it is good for AC cable, it is good for traditional MC cable, and it's good for the SmartGround enhanced type of product that's called MCI-A. So anytime you see a fitting that has MCI-A, then it is okay to use with an MC cable that's using the armor as an effective ground fault current path, like our SmartGround or even our healthcare facility type of SmartGround product. You need an MCI-A fitting. But the good news is this works on a bunch of different types of cables, AC, MC, and MCI-A. So that's unique fitting. All right, so now the next question people ask, well, how do I go from a SmartGround MC to a healthcare facility MC cable to be able to use in patient care spaces? Well, the next step for that is this product. Notice that it is still a SmartGround, but this one has a green wrapper on it. Now, again, there's nothing in the codes, whether it's UL 1569 or the National Electrical Code, that says that you have to use green for a healthcare facility. But it's pretty universal that when you see green on an MC cable, that it means that it's usually going to be installed in a healthcare facility. Okay? It's not healthcare or medical grade or healthcare grade. It is healthcare facility is the location. We're just confirming that this cable complies with a specific area in that healthcare facility, and that is patient care areas or spaces. So, under the National Electrical Code, there's this little section in there, 517.13a and b. Now, what does that say? If you have your code book, pull it out and look at it. But what that basically says is, for those circuits that are going to be feeding branch circuits inside of patient care spaces or areas, that the actual armor itself or the raceway has to be considered an equipment grounding conductor. And of course, with the SmartGround product, we know that it is because of this 10 gauge aluminum bonding / grounding conductor in contact with the armor, and because the National Electrical Code under 250.118 10b says that it is. So we know that we meet the requirements of the first part of that 517.13a. The second part, which makes it different than the normal SmartGround, which we told you doesn't have an equipment grounding conductor in it because we're using the armor. Now, 517.13b says I have to have an insulated equipment grounding conductor as a redundancy. So, here's the insulated equipment grounding conductor that's in there. So not only do you have the armor as a path, but you also have the equipment grounding conductor inside this product. So the difference between the normal SmartGround and the healthcare facility SmartGround is the simple addition of an insulated equipment grounding conductor. That's the only difference between the two products. Again, since the armor is being used as a equipment grounding conductor or an effective ground fault current path as well, that's when you still have to use an MCI-A fitting. And that's when one of these fittings that has multiple ratings comes in handy. Okay? So that's the difference between those types of products. So hopefully that cleared that up for you. Again, just so you know, also with the healthcare facility one, you simply take this 10 gauge aluminum, bend it back, cut it off, and so that it doesn't protrude past the outside perimeter of the actual armor. That way the fitting will fit on properly, or the connector, and then you're done. You don't need to do anything else with it. Again, that's all that you need to do for that. Now, let's move on to a different type product. Let's talk about this product. This is called, officially from UL, this is what's called an MC-PCS. Or basically, we call it MC-LED. It's a product that's designed to allow Class 2 or 3 circuits or cable in the same cable assembly as your normal power conductors. And you don't need a separation. So traditionally, you have things like a 2-inch separation that's required when you put the low voltage conductors inside of a raceway with the higher voltage type of conductors. I wouldn't say much high voltage, 120 volts, applications like that. You gotta have that separation. Well, this product is meeting an allowance within the National Electrical Code under 725.136 I1 and I2, to be honest with you, probably could meet both. And so what it's basically telling you is that as long as you put the Class 2 or Class 3 cables with a minimum of 30 mil insulation, sheathing, it's not insulation, it's a sheathing. As long as you put that jacket sheathing on these conductors, and you can put it in the same cable assembly, that's enough separation necessary, and you don't need to have a 2-inch separation. So they allow these conductors, the low voltage and the standard voltage, I'll use that better to understand it, together in the same cable and not have a problem. So this is allowed under National Electrical Code applications. Now, what about the UL standard? Well, up until recently, the UL standard kind of didn't have any guidance on that. Even though the National Electrical Code says you could do it in the cable assembly, you really didn't get a lot of guidance from the UL standard until recently. Now, UL standard put out what's called a CRD. And CRD is now addressing this issue and says that, hey, as long as this has the 30 mils of sheathing on it, very typical with a normal non-metallic sheathing type of jacket, which is for an NM cable would be 30 mils. As long as you do that, and you put it together in there, that's enough separation for the product. And so now it's acceptable under UL 1569 in accordance with that CRD, and it will end up making it into the latest edition or revision of UL 1569. So that's a perfectly acceptable product. Now, what are the advantages of this? Well, this product can save me a lot of labor and a lot of time when I'm doing systems where I'm having dimming systems inside of a large building, or maybe I'm having remote controlled systems where I'm controlling the lighting aspects of a large building commercially from a long distance away. So this product will allow me to run the low voltage applications for maybe the control applications or control circuit conductors and the power conductors in the same cable, so that when I go to that troffer or a luminaire, same thing, but there's official name. So if I'm putting them together, I don't have to run a separate class 2 or class 3 for the control circuits, for the signaling and whatnot, for the control of the lighting, and the power conductors separately. I can put them together in one product. Once they get into that product, then they will meet their required separation. That's an installation practice, and it's going to work in coordination with the manufacturers of that equipment, where they put the terminations in order to have that separation and take place. But as far as the assembly, I can run them together in this, and it's not a violation of anything within the National Electrical Code, and now UL 1569 has no problem with it at all. So that's the application for that product. Save you a lot of time and labor. You don't have to run separate class 2, class 3 for your lighting applications for dimmers or power management systems for lighting. You can do it with one cable. So that's an advantage there. The next thing I want to talk about is what happens when we have to run an MC cable in a damp, wet, or a dry location. Well, obviously if it's a dry location, I can run any of these products in a dry location. These fittings are rated only for dry locations. Okay, so that's the first basis we'll talk about. Dry locations, that's what MC cable is designed for. All right, now let's talk about a wet location. In a wet location, in order to use a type MC cable in that application, and in accordance with 330.12, which says that if you have a product and you install it in a certain environment, then it has to be rated for that environment. Well, there you go. So now I have a PVC jacketed MC product. Now, this is a standard MC. It's going to have an equipment grounding conductor inside there, but it also has a PVC jacket that is impervious to moisture, and that's the wet location. Now, if I'm going to terminate this product in a wet location, then I need to have a fitting that's rated for a wet location. So this happens to be another fitting by Bridgeport that is rated for a wet location. And that's where the termination would be. Then you'd need this type of fitting. Keeps moisture from getting into the ends and into the equipment. Now, what about if I'm using this product in a wet location, but the terminations or the resulting terminations end up in a dry location? Then I can use a standard fitting for the termination here because it's in a dry location. This fitting is not being subjected to a wet location. But the cable itself might be running through a wet location. Then that's acceptable because this is impervious to wetness and it is rated and identified for a wet location. If the termination is in a wet location, then I have to have this type fitting. If it's in a dry location, just the termination portion, I can use a standard dry location type fitting. Okay, so this is a wet location, good for use on parking decks. This is rated for direct burial. It'll be marked right on the side. I can put this in the ground. A lot of uses that I can use a PVC jacketed MC product in damp and wet locations. But that brings me to that word damp. Let's talk about that because that's the word that people don't want to talk about when it comes to MC cable. So let's dig it and discuss it a little bit. Maybe you can understand it a little better. Obviously, this product can be used in a damp, wet, or be honest with you, a dry location. Not a problem. The PVC material on top of it is just an enhancement for that application. If it's in a dry location, it's just an enhancement. You also have to remember there are other adjustments and corrections applications that are in the National Electrical Code that'll say, look, you can get some allowances with MC cable as long as it's not jacketed. So keep that in mind if you're going to have an issue with bundling or if you're going to have an issue with the ambient adjustments or whatever when it comes to the jacketed. But on the surface, you could use this in a dry or wet or a damp location on the surface. So keep in mind about adjustment and corrections. But that's the general rule. But let's talk about your traditional MC cable. And this one, I know we remember that this is blue, so this is a steel armored MC cable. Now what if I want to install this in a wet location. Can I do it? Even though I know the conductors inside of here are rated for wet location. They're probably going to be a THHN/THWN-2 or an XHHW-2 depending on the product you buy. Yeah, the conductors are rated for wet location, but the armor itself is not, and it wasn't evaluated for it. So that's where your problem. Now, where are we going to go for some guidance? If we look in the National Electrical Code, specifically under Article 330, you're not going to see the word damp appear anywhere within 330.10. You're not going to see it. You'll only see references to dry, and you're only going to see references to wet. Now, what about the UL standard, UL 1569? If we go look at that standard, what does it say about damp? You're not going to see that word anywhere in UL 1569 standard. It's either dry or it's either wet. This is identified for wet. This is evaluated for dry. The fittings that go on it are rated for dry location. So you kind of see what's going on here. This is a dry location product, regardless of the conductors that are inside. So why do we put conductors in there? Why don't we just put THHN in it, which is a dry conductor only for dry location? So why do we put the dual rated in it? Well, there's an important significance to that. Under the National Electrical Code, if you look in Article 100, you'll see a definition of what's considered a dry location. And to paraphrase, the dry location is an actual location, but it could be subject to temporary times where it's subject to wetness or dampness, like in such cases of construction. It's still a dry location. Just because it's subject to some dampness or wetness due to the construction process doesn't make it a wet or damp location. It's still, at the end of the day, when all is closed up and all the walls are done, is it going to be a dry location? Yes. Accidents happen. With this product, as long as it's not saturated, as long as water doesn't get into the ends of it that can wick down into it, and it's sitting in it for a long period of time, if it's being run horizontally through ceiling and there's some flood, say from a room above or maybe an apartment above, and it simply flows over the product, you got to remember the conductors inside are rated for a wet location. The armor is what we're trying to protect with this PVC material, okay? But it's not being subject to a condition where it's going to always be wet or it's going to always be damp. It's a dry location subject to temporary wetness and dampness, okay? So that's where this product can be used. So if it's installed in the walls and it temporarily gets some rain on it or some moisture on it and it doesn't really saturate it or doesn't get submerged through flooding, because if it's a flooding condition, you need to refer to the NEMA document for water damaged electrical equipment, and that's going to give you some guidance on what to do with this cable when it gets submerged or the ends get wet. But for the surface here, water simply going over it, it's not going to affect this product. And again, the conductors inside of it are rated for wet location, so we feel confident with that. That's not to say that this is okay to be put in a damp or wet location. It is a dry location rated product. This is a dry location type of fitting. Okay, so keep that in mind. Now, what about a wet location? What can I install in a wet location and a damp location with 100% certainty? PVC jacketed MC with 100% certainty I can install in a damp or a wet location. Now, because the NEC doesn't reference damp, because UL 1569 doesn't reference damp, where am I going to get the guidance that says that this cannot be installed if it's a dry location product where I can't specifically install this in a damp location? And the opinion of us, the manufacturer, is this. If you look in the National Electrical Code, again, UL 1569 is going to give us no direction here. So from a manufacturer standpoint, we could actually say we don't care. But the reality is we like to make products that are in conformance with what the installer is going to have to face out in the field. And in that case, you're going to look at 110.11. And 110.11 is going to say that, look, a product has to be identified for its use. This is identified for a dry location. This is identified for a wet location. Thus, more restrictive being wet clearly can be installed in a damp location. So the identification for this product can go both ways. This product, it cannot. So, unless we identify this product for use in a damp location, then it's a dry location only type product. Again, that is the location. Not having this cable subject to some mild degree of moisture due to construction or due to a freak incident, that's different. As long as it's not submerged, And as long as the water doesn't get into the ends of it or any contaminated flood water gets into it, that changes the game. All right, so it's really important to know what kind of exposure this cable has been faced with. Then we can give you some guidance after that. But this is a dry location product, wet and damp location product, dry location fitting, wet and damp location fitting. And it's just that simple. Well, hopefully I've explained a little bit more about the MC products, their installation, their usage, a little bit more about the fittings. And hopefully if you have any additional questions, you'll reach out to us here as we do more segments here from the desk of Codes and Standards here at Encore Wire to try to get rid of some of the myths and some of the issues that people have on the different types of products and their use and how they're used and things like that. So hopefully you'll join us next time for the next series of videos on From the Desk of Codes and Standards. My name is Paul Abernathy, and again, if you have any questions, feel free to email us at codes@encorewire.com.